What's up, baby bio penguins? So, as we've publicized and we've mentioned that tonight is our Unit 2 live Q&A, and we will be meeting up with the APsolute RecAP. Melanie should be joining us moments from now. I sent her a message. It's like, let's ready to party, although I may have made a spelling error in there, so, you know, fun stuff. So, before she gets in here, just as a quick reminder, Unit 2 is about the cell. And so as you're coming in, go ahead and put any questions you have about the cell into the chat. So that would be all the organelles of the cell. That would be membrane transport. And also, if you want to go ahead and say in the chat where you're from, we want to, of course, welcome everyone. It looks like that the APsolute RecAP is here to party with us. So hi, Melanie. Where's she at? I know it says she's connecting, so she should be here just momentarily. There she is. Hi,
hello. Round two,
Unit 2. How are you doing this evening?
I tell you what, when we decided to do these on Sunday nights, I was like, yeah, Sunday nights, great way to start the week. Students, we know you're super busy on Sunday nights trying to get ready for the week. Teachers are as well.
Right before we started, I was like last minute trying to put together my Bitmoji classroom for the week. I was like, oh, let me skip this. I'm like, oh wait, it's 8 o'clock.
Yep.
So
I have to finish making some FRQ portions of a test for tomorrow after this live.
Oh wow. Okay, so welcome everyone. I know I've welcomed many of you already, but quick reminder, down in the bottom you'll see a little question box. Question box is for you to submit questions. Tonight is about questions and answers, okay? You submit questions, and we will answer whatever questions you have about Unit 2. So Unit 2 is on the cell and membrane transport, as I mentioned a moment ago. So Melanie, what's your favorite organelle, just before we get some questions in there?
Okay, I have to have one, right? So I like the Golgi apparatus because it has like 12 different names depending upon the textbook you read, and I just like to say the word apparatus. It also reminds me of a lava lamp, the way that it buds. Ooh. And I wasn't allowed to have a lava lamp as a child, and so I would always watch them at my friends' houses, like blubbing off in little pockets, and that's my Golgi. What about you?
I guess my favorite would have to be the Endoplasmic Reticulum, because of the backstory of it. Because the Endoplasmic Reticulum was named that because of purses, and I think it's like really cool connection that there was like this purse out there that looked like a net. And they're like, hey, this organelle looks like that too. Let's name it that. So I guess we'll go with the ER.
Yeah. And my favorite question, as always, like, do we have to spell it out?
Yeah. And speaking about the Golgi that you mentioned before, students, be sure that you are aware that there are multiple names for things.
Yes.
And so the question writers can actually choose any of those names, and you must be able to know that it's the Golgi body and the Golgi apparatus and
Golgi complex.
Golgi
complex. Yep.
Yeah. So you need to be aware that there could be multiple names for it. Same thing as the Krebs cycle is also known as the, oh my God, my mind, citric acid cycle.
Citric acid cycle.
And
or the TCA cycle.
Yes. So be aware that there are multiple names for something. So be sure that you know what those names are. So let's see if we can jump in this and do some questions. Oh, you all are we're going to go with some easy ones real fast here. There are some loaded questions in the question box.
Oh my, okay.
So remember that when we're watching this later, you can't see the question that pops up. So real quick, let's just say the question and then you can jump in, Melanie. I'm cool with you answering.
No, that's fine.
I
just realized we didn't introduce ourselves.
Oh, we didn't. I'm sorry.
No.
I'm Miss Jones. Okay. I'm in Georgia, and I teach AP biology. Been doing it for about 10 years now. Woohoo!
I'm Melanie Kingett. I have been teaching AP biology for far fewer years than Tiffany, but I am the co-founder, that's the words, of the APsolute RecAP. So I produce the biology podcast, and I write all the biology episodes. So if you've been a listener, thank you.
And remember that next year when you're in chemistry, or the following year when you're in physics, Melanie also has podcasts for that. So if you have any friends of yours that are taking chemistry, physics, Was it government?
Government and music
theory.
theory. Yeah.
So
everybody always
sure
forgets about music theory, but like, gotta represent.
Okay, so our question is, how do you find the orientation of a phospholipid?
Mm-hmm.
So do you want to jump on that
Find it from a diagram, or I assume that's what they mean.
I'm assuming they're probably talking about, like, because there's a best way to put this. If we were to have like an artificial cell, and the outside is, non-polar.
Oh my goodness.
And the inside is polar. How would that phospholipid orient?
Crazy times. So phospholipids are amphipathic, and our prefix amphi tells you that it has both qualities, essentially. So we have non-polar fatty acid tails, and we have polar heads that are going to be attracted to other polar things.
And so in the example I just gave, which way would we find those tails facing? Which way would we find the heads facing?
Let me see if I can remember what you said.
I said non-polar,
I believe you said non-polar,
extracellular,
yeah,
and then polar intracellular.
All right, so the head portion would face internally, and the tails would face to the extracellular environment.
And so the example that I gave was giving different polarities inside versus outside. And so traditionally, when we find our cells, they're in aqueous solution. So our intracellular and our extracellular is actually normally going to be polar. And so if you're thinking to yourself going, wait a minute, they just mentioned a single layer. Well, that's why. It's because normally we have polar internal and polar outside. And so you have to have two layers in order to have your heads facing out and your tails facing in.
Let me ask you,
are not functioning.
Are you always asked this question every year? I'm always asked, what happens if you put a single phospholipid in water? Are you ever asked that question?
I'm never asked that question,
I've
but there's
always
actually a
asked that
question
question.
that's in there's a practicing biology worksheet that I give my students, and it's in there where they have to
spins,
show what
right?
would happen. Yeah, I guess it could spin. It's logical because it's gonna. Yeah, but if you have multiple, they're gonna kind of get together. But yeah,
they always ask me if there's one. What if there's only one? It's like, okay, well, that's improbable.
Yeah. Okay. So we did that one. So let's jump into this. How is prokaryotic cell compartmentalized? So here's the thing, like before we jump into the two different types of cells, let's think about, well, actually, before we jump into organelles,
right?
Prokaryotes versus eukaryotes. Prokaryotes are going to be before nucleus, so they have no membrane-bound organelles. So when you think about all the organelles, you think about endoplasmic reticulum, you think about Golgi, you think about lysosome, you think about all these other organelles. All of those have membranes on them. So what is the only one, and let's go ahead and answer down in the chat, what is the only organelle that doesn't have a membrane? So think for a second, what is the only organelle that doesn't have a membrane? And so since we already mentioned that prokaryotes don't have a nucleus, they instead have this nucleoid, right? And so because of their small size, and because actually prokaryotes aren't compartmentalized, we're going to actually be able to have the prokaryotes are a lot smaller than the eukaryotes. And has anyone answered? Did I miss anybody answering?
I didn't see anything yet. So we're asking, what is the only organelle that does not have a membrane? And if you're having trouble thinking about it, go back to
nice job,
ribosomes.
Art.
Yeah, hello, Art. Go back to thinking about their functionality, right? So membranes separate different environments, essentially, whether the environments are internal, like organelle to cytoplasm, or if they're from cytoplasm to extracellular environment. And so that's going to allow us to do a whole host of things by having like little Goldilocks zones in different areas. But ribosomes aren't going to set something up to occur across a membrane like so many other organelles. They're going to have, well, we can talk about ribosomes in a minute, but yes.
But you are right, everyone who's currently writing ribosomes in the chat. Good job. Ribosomes are the only organelle that we're going to see inside of our prokaryotes. So then when we move into our eukaryotes, they do have compartmentalization. And the only reason why is so that those cells can be bigger. So I'm sure you all have looked at the math in this, in which we have surface area to volume ratios, right? And we want our cells to have a large surface area to a smaller volume. And the way we can do this is, number one, compartmentalizing our cell. And number two, we can extend our plasma membrane in some way. There's different cells in your body, for example, microvilli. I'm sorry, cells of your intestines that have microvilli.
Microvilli.
And so there are these long kind of folded areas. Projections, yeah.
Yeah.
That help to increase the surface area so you have more area to absorb materials in your intestines, but it doesn't increase those cells.
Name of the game is efficiency, that's for sure.
Efficiency, yes. And so the question was about how prokaryotes are compartmentalized. They're not actually. But our eukaryotes are, and it's because of the fact that we need them to be big, and the why can't I talk tonight?
I think you're trying to say carboxylic acid. You might be going into like...
I don't know what I'm saying. Can you please say the word for me?
Compartmentalized.
So the reason why they're that is so that they can be large, and so that there's different functions occurring in these different areas. And so when you think about the different organelles, they all have a specific function. When you were in middle school, you probably had to do a project in which you made each organelle into a part of a city. And that is where everyone comes up with our favorite phrase.
No, don't say it.
The mitochondria is the, oh no, I can't even say it. Y'all are probably screaming it right now at home because I cannot say it.
My students troll me with that. They like to like write it and hide it in different parts of the test or quiz or worksheets, like off on the side, just because they know. Just because they know. I don't want to see it.
Gotcha.
I don't want to see it.
I'm seeing a lot of questions coming in that are not Unit 2 questions. So just a quick reminder that tonight is Unit 2. So it's about the cell organelles and about membrane transport. So I'm honestly going to skip the ones that aren't about Unit 2. I might write them down for the future, and maybe we can do them when we do those lives. But we're going to sit just in Unit 2 here. I guess we're going to have to go to the loaded question because that's the only one left. How do you remember the organelle functions?
Oh.
There's so much to remember, plus what they do. And additional information, types of RNA, compartmentalization, like it can't even fit the whole thing in that question. Like it's just so
all right,
long.
so how to remember all the organelle functions.
Okay, so I like to kind of think about it more on the pathway of gene expression. And that's how I get my brain around it. Okay, so our nucleus is going to be the location in which we have our DNA. It houses the DNA, it houses the information for the cell. Okay, so if you really want to get into our little metaphors here, it could be like a recipe book. Okay, and so in the recipe book, you know, Grandma wrote down this recipe long time ago. It's in this beautiful book, and you're like, oh my God,
and you can't read her handwriting in some of it.
But this is a very, very, very sensitive piece of paper because it's not just like this has been in the family for years. Like if you don't want to lose it or you don't want to destroy it. So what happens inside the nucleus is you then make, of course, the mRNA that leaves, right? So the mRNA is going to be like you writing down that recipe on a piece of paper, and it goes to the rough ER, okay? So the rough ER is where we're going to, of course, make our protein for membranes. There are also, the reason why the rough ER can make proteins is because of the fact that there's ribosomes that sit in the membrane. And quick thing, just because I know the students make this error, there are 2 types of ribosomes. Melanie, what are the 2 types of ribosomes we got?
No, the one you find in prokaryotes, the one you find in eukaryotes.
No!
Oh, cytoplasmic and plasmic reticulum, sorry.
Okay, so we have cytoplasmic.
But that was a right answer. They're different in prokaryotes.
I will let you have that answer. You are right. They are different. They are similar to our mitochondrial prokaryotic. I mean, our mitochondrial ribosomes. Anyways, so
I wonder why that is.
Are for cytosolic. Okay, they make, of course, the proteins for the cytosol, versus our bound ribosomes that are attached to the ER are going to make the membrane proteins and the proteins for secretion. Those are the exact same ribosomes. The free ribosomes get a signal that then causes them to move to the membrane to put the protein into that membrane. So they're actually the same ribosome. They just pop off and on.
Anyways, around.
Yes. Huh?
They're just shuttling around.
But yeah, they're shuttling around.
Yeah.
Just like everything else in the cell just keeps rotating around.
Moving around.
Yeah. So after we leave our rough ER, it's then going to move into our Golgi. Oh no, Melanie's favorite. Organelle, which we're going to package and we'll modify. So there'll be slight modifications. For example, like insulin. Insulin has to be actually cleaved and has to be cut and then rebonded in order to be functional. And so we all know insulin is essential. So of course, for blood glucose levels to drop. So we have to, of course, make a functional insulin. And then it, of course, can move to the plasma membrane, which plasma membrane is a non-organelle. But so thinking about the fact that we just made these proteins inside of a outside, so that can also move to be a lysosome. So if we make hydrolytic enzymes that go through hydrolysis and break things down, then it can use the function of digestion. So kind of thinking about what's inside of them helps you to kind of come up with their function. If you have hydrolytic enzymes, it's going to be in charge of digestion. And then, you also have their smoothie R, which is our membrane factory. Is going to make our steroids. It holds our calcium. Oh gosh, there's more. Oh, detoxification. Yeah. And so the thing that we need to keep in mind, though, is that we've just mentioned things that are regular biology, right? If you talk to any of your friends who are in regular biology, you think back to when you took regular biology, all that I just said was all regular biology stuff. AP is going to require a application of it. There is a disorder called Tay-Sachs. In Tay-Sachs, there's an accumulation of lipids in the brain. Which organelle is non-functional? Oh my God, what organelle is non-functional? We're talking about that something can't be broken down. So, let's go ahead and in the chat, see if you can tell me what organelle is non-functional, because we're seeing an accumulation of lipids. We're seeing that something is not being broken down. And while you're doing that, we're going to kind of think about some other functionality. So, Melanie, how do you remember the organelles? Because I said how I remember.
Yeah, you did. It's interesting because I don't think I've ever thought about it. I'm a much more diagram-oriented person. Your explanation was, I think, a lot more story style. No, and I think that that's great because everyone kind of leans in a different direction. I like to think about functions associated to structures. So for me, and not all diagrams are created equal. The best ones are going to be things you sketch out yourself that make sense to you. And that's really important to, I just get on my soapbox for a second. Some of the earliest scientists were the best artists, and that's not an accident. So doesn't have to be, Galileo, but quick little sketches of your understanding, then comparing them back to, official resources is just a good skill to practice. So for me, I like to, if I focus on the mitochondria for a second.
Oh my God, I didn't even say the organelle mitochondria. Go for it.
You were talking about protein synthesis, so we'll let it slide. We're going to have to have our moment with chloroplasts and mitochondria, I think, in a little bit.
Oh yeah.
But so as my example of how do I remember the organelle functions, for me, and I look at the mitochondria, I have to draw on it, on the cristae, talking about the different membranes. Where are my hydrogen ions? I have to draw it so that I can see not only that it's just a term, but this term is a piece of something and has a function, and I can work through that function. Because like you said, Tiffany, we're going to get a situation where something doesn't work or something's disrupted, or you're given an unknown cell and trying to work it from there. So I don't like to kind of pigeonhole my understanding into one idea. And I think that for students, that can be unsettling because they want to know what the answer is. There's only one answer. And while that's still valid and true often, it's not going to be the one I'll say memorized, even though I don't encourage memorization.
Okay, so I'm seeing a lot of individuals that are putting lysosome in the chat for my question about Tay-Sachs. So great job, everyone who answered lysosomes. I did see there was a not sure, which is awesome. I'm glad that you have given your honesty there. That's great. So this is the places that we can grow. And as Melanie mentioned, she's very diagram friendly. She loves her diagrams.
I do.
If this was a normal school year, I would be actually sitting at Panera, and I wouldn't be doing live sessions. I'd be just sitting at Panera doing my sessions with my students. And
wait, what? Wait, what?
Well, I mean,
you go to Panera with your students? That's awesome.
I do.
I didn't know that.
Yes. So I only let 10 students come at a time, and we sit at a long table in the corner. I get there super early in the morning, the first people in the door, and I just sit there and I just draw pictures. I don't reteach them anything. I literally just draw diagrams, and we just do graphic organizers. So I think that it's good for students to see things different ways. So definitely, if you're a visual person, sit down and graphically organize your unit and draw like bubbles or like make
Mm-hmm.
little diagrams. If I could find the piece of paper, I would totally show you one right now, but I can't find my papers right now because I wasn't
I
prepared to
think
talk about
I
this.
think it's so obvious when you're showing your understanding visually when you hit a wall. Like it's so obvious because you like run out of explanation. I think a lot of students can kind of trick themselves into explaining something in a paragraph. By talking in a little bit of a circle, repeating information just like the same way. Whereas going through a flow chart or going through some sort of diagrammed explanation or table, or you just see the holes in your knowledge a lot better. And that's really the point of studying. Find your holes.
And also thinking about, you're talking about the diagrams, you can
Yeah.
diagram your free responses. As you're writing a free response, you're reading a free response, diagram what you're thinking is the thought. So for me, when I answer free responses, I somehow give my justification before my prediction because I'm like writing out my explanation why this is going to happen. Da, 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 and I go, okay, and then this is what happens.
Right.
Because I think through it as I write it. And so that's a great kind of thought, is to draw it out, map it out. You have a 10-minute reading period that you can use to map things out. So definitely.
And I'm glad you just said that, because I think it should be noted that diagrams in and of themselves are not answers to FRQs.
Oh, yeah. Well, if you do a diagram, make sure that
Right.
you label it. Say,
Yes.
as seen in figure 1, and then you have your diagram, this is what happened. And so like it helps you to demonstrate to the readers, because sometimes things like crossing over is hard to verbally explain. Right. And so like drawing them the picture so they can see what you were talking about helps a lot. Anyway, so back to our question. We have actually 2 people who asked very similar question about this. I figure we should jump right into it. Can you talk about the endosymbiotic theory? So I know that this is evolution, but it also really ties into the mitochondria and the chloroplast. So that's why I'm letting it slide. Plus 2 people asked it.
I think this is totally valid. You can't talk organelles without talking about the endosymbiotic theory. Oh, hold on, we have an explanation.
Emily's just jumping right in there.
So
2 smaller cells containing either mitochondria or chloroplast engulfed by a larger membrane, creating eukaryotes. Okay, you are right to a small extent. I need to modify your answer slightly. And it's a great answer. No judgment there. That you need to mention that all of them had to have mitochondria. Not all of them had a chloroplast, but all of them have a mitochondria. And the reason why we know that every single one of them had a mitochondria in this case is the fact that all eukaryotic cells have a mitochondria, but not all eukaryotic cells have a chloroplast. So great explanation, but you can't say mitochondria or chloroplast. You can say mitochondria or mitochondria and chloroplast.
One of my favorite kind of like, I think we actually talked about this before, but like one of the questions that where in a eukaryotic cell would you find DNA, right? Where could you find DNA, right? And so you're like, okay. And it's like, even so, where in a plant cell could you find DNA? You can get even deeper. So obviously you're going to have it in the nucleus. You're going to have it in mitochondria, and you're going to have it in chloroplast.
Exactly.
Anywhere else? Did I miss any place?
No, that's all the ones I know about. Well, since we're speaking about that DNA, be sure that you are aware that there are some inherited disorders that occur because of diseases within the mitochondria or the chloroplast. And so just giving a quick bump in this, and we'll re-hit it when we get into unit 5 something. I think it's 5.
5 something.
I don't have 4, 5, 6 memorized because I don't teach them correctly. I don't teach them in the order that they say. But so
that's always teach them correctly. Let's hope.
I teach them correctly, but not in the right order. Like I make a 4A and a 4B, which is 4, 5, and 6, like shoved together because I'm crazy. If you haven't figured that out yet. Anyway, so the egg. And so the egg is always going to have the mitochondria and the chloroplast in it. So it will always be inherited from the mother. So that's what I was going to say about the mitochondria. But anyway, symbiotic theory was all just basically talking about that there was a larger cell that engulfed a smaller cell. And that's why we say it's the mitochondria and the chloroplast. We believe that they are prokaryotes that have created a symbiotic relationship with the larger cell. And there's evidence for this. There is the fact that they have a double membrane. And as Melanie already mentioned, they have their own DNA. And that DNA is circular. And as Melanie also already mentioned, they have their own ribosomes. And those ribosomes are similar to a prokaryote ribosome. They
They're
replicate
also
by
the
binary
same.
fission. What did you
They're the
say?
same size too.
They're similar
about the
size
same
to
size.
prokaryotes.
Yeah.
So there's a lot of things that kind of help you to see that they might be, actually the evidence, which is one of the things you're going to have to give on the AP exam, is provide evidence to prove this claim or to support this claim. So that would be
And
right there. You're giving evidence.
I saw back in the chat, it says, so mitochondrial diseases were maternal, correct?
Correct.
You might have touched on this, but it glitched. So yes, for AP Bio and the CED, that is correct. There's some modern data that suggests otherwise, but we're going to go ahead and yes, that's true.
I'm going to say yes. Okay. Whew. So I hope that everyone's doing good tonight and we're enjoying this. This is going so okay. Let's see. We already had the endosymbiotic theory. Okay, so thinking about
guys, don't forget this is also about transport. So
I know that everything we see is organelles.
Yeah, we're going to want to talk about transport at some point,
especially talking about hypotonic, hypertonic, and isotonic. So what is the difference between lysosomes and peroxisomes? So you want to take this one, or I can take it. Doesn't matter.
Oh, sorry. I think it's glitching. I can't hear.
What is the difference between lysosomes and peroxisomes? Sorry. Oh, Melanie, you're glitching again. Is it me or is it you? Is it me? Oh, no. All right, I'm just going to give the answer then. So the lysosomes is where we're going to digest. One second. She's asking me a question in the chat. So the lysosomes are where we're going to, of course, do digestion with hydrolytic enzymes. The peroxisomes are detoxification, and they use they actually like make it into hydrogen peroxide and then break down that hydrogen peroxide using an enzyme that some of you may have used in lab this year. It's a weird year due to COVID, so some of you may not have done the traditional lab. Usually we do a lab with catalase. So this is an enzyme that will break down hydrogen peroxide into water and oxygen. And so peroxisomes actually have catalase in them, and that's why if you cut your finger and you put peroxide on it, that's why the peroxide bubbles, is because those cells have been broken open and the peroxisomes have released their catalase, and so that catalase is breaking down the hydrogen peroxide, producing the oxygen to help clean the area, which I always thought was cool.
It's super cool, but isn't it not actually any better than water and soap? Hydrogen peroxide.
Yeah, I don't think it's any better, but it makes you feel like something's happening because it's like bubbling. You're like, ooh, this is something cool.
Science.
And it doesn't burn like alcohol, so little kids are like, yay.
Yay. Do you use potatoes for your catalase lab?
Oh, no, I order like bovine liver catalase from Carolina. It's like comes in like this little powder. I add water to it. I shake it up, keep it on ice, and it's good to go for the whole day. Okay, so let's get to the plasma membrane again. So what is the function of steroids in the plasma membrane? And so I think
we answered this one last time. I'm assuming so. I hope so.
I'm sorry. Okay, well, can we do it again? What's the function of cholesterol?
Yeah, for sure. So temperature regulation primarily.
We did talk about this, right?
We did, right? Because I made my little fatty acid tail and you thought I was taking a picture.
Yes, you're right.
Steroids are lipids. They are carbon rings. So we have to remember lipids look a little diverse in their structure, but they are all nonpolar. And so we think about phospholipids, because we're sticking this in the membrane. Location is important. We have to have nonpolar things hanging out with nonpolar things. So if you look at a diagram, you're going to see 4 carbon rings, and it usually is like the same length as the fatty acid tail, but that's disproportionate, correct? That wouldn't be as large. Yeah. No.
She's bringing up a little bit. Sorry. So speaking about the nonpolar region, let's go ahead and talk some transport here, because I find that this is important to know. Since we're talking about things getting across the membrane, right? And we're talking about that there's this cholesterol that sits in that nonpolar region. So there's 2 different types of messenger molecules you could have, signaling molecules. You could either have a polar molecule, like a protein hormone, or you can have a steroid hormone. And so it's important to realize which of those can get across your membrane. So your steroid hormone can pass directly through the membrane. It does not require a transport protein because of the fact that it can get straight across, and so the receptor will actually be on the inside because it's nonpolar, so it can pass directly through this nonpolar region without having any type of issues. Versus a protein hormone is going to have to bind to something on the membrane. It's not going to come through the membrane anyway. It's going to bind to a receptor molecule on the membrane. So it's important to know that. She's currently spinning, so I don't know if she's with us. There's a reason why I host. When we did this last year, I lost her multiple times, and whoever's hosting, if we lose them, the whole thing goes away. So this way she can come in and out. And as you just see, she left. And by her leaving, it doesn't actually close the thing, the live session. Okay, so let's jump into this real fast. And before we go into that, that's hormone steroids. Yes, steroid hormones are the ones that can get directly through the membrane versus our protein hormones are unable to get through the membrane. And so let's quick think about the three different terms that we mentioned earlier. We have hypertonic, hypotonic, and isotonic. And I swear I just let her in. Oh, there she is. Okay.
I need to get a new phone. I think I'm going to do that before our next live. I just can't do this anymore. Okay, can I interject briefly? I left during proteins and steroids. And okay, did we say the word ligand?
I did not say that word. You good? Say it.
Okay, great. New vocab word. So what was I going to say? Oh, it's gone. Anyways, ligand. Keep going.
Ligands are going to be your signaling molecule, and they bind to a receptor. And so the important thing about that is that they cause the shape change or the conformational change to your receptor. I kind of was thinking we would hit ligands and all that when we got into the
we pronounce them differently.
Do you really? You call it a ligand.
I call it a ligand.
Yeah, but as long as you don't call it telophase, we're good.
Now I gotta think about it. No, I don't.
All right. So before, when you left and came back, I popped the question up, and it's talking about hypotonic. So I figured before we answer this question, I was going to go over the different hypo, or isotonic. So if you want to take that, you can go ahead. What are the three different types?
Yeah,
of
for
solutions?
sure. So our prefixes are going to refer to our solute concentration. Right? So hyper is low, hyper is above, and then we have iso, which is equal concentrations, not equal amounts. Okay, and that's important to reference when we talk about the movements of either water or our solutes. So a hypotonic solution will have less solutes when compared to something else. These are comparative terms. You're not going to have something that's hypotonic and then like empty space. Okay, you are typically going to be referring to something on one side of a membrane to the other. And these are going to be dissolved solutes traditionally in our terms. So when it comes to talking about the movement of molecules, whether it be movement of solutes or movement of water, you have to be very mindful of the terms that you use. And we'll come back to those in a few examples in just a second.
And so like with my students, I always make sure that they know the direction of the water movement. And I always tell them to go hypo to hyper, hypo, hyper. I don't know. Anyways, and my old partner teacher used to have to talk about like hippos, and hippos live in fresh water. And so they're
say that.
They're surrounded by all this water. So hypotonic is kind of like you think of like a hippo. And so it's a whole bunch of free water. And so it kind of helps you with remembering that because everything moves from high to low. But the problem is with these problems that they give you an amount. So they'll say you have a 0.2 molar solution and a 0.4 molar solution. Okay. Well, that trips up students because the student goes, it goes from 0.4
high to low.
0.2, high to low.
Right.
But the number they gave you is a solute. So you have to remember that we're going from where there's more water to where there's less water, or more free water to less free water. So that 0.2 molar solution has more free water that's not currently bound and surrounding solutes, to hypertonic, where there's more solutes, so there's less free water.
So I teach at an all-boys school. which lends itself to some like really bizarre analogies. I mean, when we talk diffusion, we always talk about passing gas and solutes bumping into each other. And, oh,
I
yeah.
love it.
It's that whoever smelt a Delta day when we talk about it in class, and who would get
I
it
pretend
first
like a student in my room has smelly feet, and I spray a whole bunch of air freshener near them, and then I like act like they stink and walk away from them. They like look around like I didn't do anything. It's the greatest experience ever.
The things
then when
we
I
do,
finally explain
right?
it, they're better.
Right.
So it says, how does a cell wall protect the cell from a hypotonic solution?
Protect it. Do they mean from bursting? Is that what they're implying?
They're implying, yes, because well, then let's think about it real fast. Then hypotonic, if you put an animal cell in hypotonic, it's like a water balloon that you keep putting water in. Sooner or later, it's going to bust. Versus if you had a jug of water and you keep adding water to the jug, sooner or later you can't get any more water, but the jug doesn't really bust.
How important is it, do you think, the knowing the terms like crenate and cytolysis?
They'll be in a question, but I don't think they have to say them. So like they may tell you that a cell has crenated, but I don't think that they'll just keep those solo. They may say the cell has shrunk or crenated, and then later on mention the word crenate. Like, why did the cell crenate? But I don't believe that a student is going to individually have to know those terms.
Okay.
So the way that the cell wall protects it is it kind of provides a pressure back. So provides positive pressure. And so if you're thinking about water potential, sorry, my phone is for some reason there keeps getting these notifications popping in. So I'm trying to like get them to go away and they won't go away.
So even though I'm crashing, I did put my phone on do not disturb. I did think to do that. So everyone, you know what? By the exam review, the last Insta Live we have, it's gonna go great.
Oh yes. Hey, I think we've already started doing better than last time. Like last year, that was 3 videos that made 1. Anyway, so the cell wall kind of helps to protect. We also thinking about surface area volume ratios with plant cell versus the animal cell. A plant cell can be larger than an animal cell, but have the same surface area to volume ratio because of the central vacuole. So we didn't mention.
I thought you were going to let them guess.
Oh, I'm sorry. The central vacuole is this organelle that kind of is only in plant cells, and it holds water and other solutes, waste also in there. And so it takes this big part of the volume of the cell, and so it allows the volume of the plant cell to decrease so they can be larger cells, even though they have the same surface area to volume ratio. Hey, I finally got the hearts on me. Usually when you're talking, the hearts show up, but they finally showed up for me. Yay!
I didn't notice at all.
Yeah, it's always shows up only when you talk.
So my entire face is just blocked by the question box for most of the time. So like so I'm just like, it's fine. I know that on the video, you'll see my face. So I try to like just assume that I'm still smiling.
Yes, you will definitely be.
All right, we have a question about secondary messengers. Guys, secondary messengers.
Go ahead and take that
while
I'm looking for another question.
We will definitely cover that. Yeah. For Unit 6, how they promote and inhibit mitosis.
I think she's reading something.
Trigger pressure.
The question I just covered her face up with is, what is osmolarity? So osmolarity is more or less just looking at the hypotonic to it. We just decided that we were going to make it a little bit more complicated by adding a new word. So they'll say that something is hyperosmotic. That means it's hypertonic. Hypoosmotic is hypotonic. Like, it's basically the same word. I just wanted to add a new vocab word just to drive you crazy.
It's like when we talk about diffusion and then we talk about osmosis, which is diffusion of water. Unless you guys don't forget about aquaporins, guys. If there's a lot of water to move, you'll need a protein.
But water can move through the membrane slowly.
Yes.
I got caught on that one. There was a question that came through and I'm like, oh, water can't get through the membrane. And I got it wrong. And it was because of the fact
that... As a student?
No, like as a teacher. Like I was looking at it because I completely didn't realize that there would be a small amount of water coming through the membrane. And like so
a trickle, it's like a little leak.
Yeah. And I said this last time.
teachers make mistakes. Like, we're not perfect.
All the
We
time.
don't know everything. And that's honestly why there's two of us in this room right now. Is because between the two of us, we should have all the other stuff for you, right?
I have on, I think, at least 3 occasions published an error in one of my podcasts that I had to go back and fix. So, and it's mostly because we think a little too quickly sometimes, that we just jump to like a place and then we're like, oh no, wait, that wasn't correct.
Or like you're in the middle of saying, you're like, wait a minute, that doesn't sound right. So high osmolarity, and please correct me if I'm wrong here. If they're saying that something is high osmolarity, that means that it's high amount of solute, and low osmolarity means low solute. Somebody asked the question that says, what about low osmolarity?
Low osmolarity.
And I don't really use the term osmolarity too often. I'm trying to like remember like what high versus low osmolarity refers to.
Are they talking about like water potential calculations? Is that where they're
I don't know. Samantha, do you want to give a connection to what you're, because I think that low osmolarity is talking about it's a low, like it's low amounts of water versus high osmolarity is high amounts of water, but I don't know. I think I just said backwards what I said the first time. As you can clearly see, I don't use osmolarity very often when I talk about this stuff. Okay, so let's see what other questions you have.
So we were talking about water. We were talking about water moving, and so just like to broad stroke it, large and charged, not going to pass through. Going to need a protein. Okay, small, nonpolar, can pass through the membrane. Obviously, water is neither large nor charged. It is small, but it's also polar. So that's why water bucks the system in a lot of ways, because it's just such a unique molecule in the way that it behaves, but it's very small. And so in very small doses, it can kind of sneak through the phospholipids that are adjacent to each other.
So the question we got, it's good to know that it's not that frequently used. The questions that I've seen it on, it's a free response question, and the student could say the word, but they could have said like 20 other words, not really 20, but like 4 other things they could have said. They talked about hypertonic, they could have talked about like the polarity of, they could talk about water potential, not polarity, water potential, they could talk about osmolarity, or they could talk about tonicity, which is hypertonic, hypotonic. So honestly, I wouldn't be too stressed out. Low osmolarity is less solute, and high osmolarity is more solute. Thank you.
Okay.
I don't even know how to pronounce that username, but thank you.
I think that's what you said the first time, so we'll go with that. Your gut was right.
My gut was right, and
but
students do know
regardless,
that,
use your use your nouns in those questions. That's the big thing. Don't like not attempt a vocab word because you're trying to talk around it. It's very obvious when you were like it and they and that, and it's like, okay, but what are you talking about?
Right. And so, as you just said, that my first answer was right. A lot of times your first answer is right. You say that first answer and you go, yeah. And then like you start thinking about it, like, wait a minute, am I wrong? So I've always like taught my students that unless you can give a good reason why you're wrong, don't you dare change your answer. Unless you can completely argue against that answer and get yourself out of it. Because usually your gut is right. You usually have the right answer first. So trust yourself.
So the dialysis bag, I mean, there's like 12 different ways to do that lab. But dialysis
I think they're talking about
tubing,
the generic one.
Yeah, the dialysis tubing is basically like a synthetic membrane. It has pores in it that you can't see. It's plastic. And so those whole pores are going to be of a relatively small size. And so in the context of using starch is a complex carbohydrate, which is a large molecule and typically not going to pass through those small pores. If we think about what the lab asks you to do, it's usually going to use an iodine indicator, which in the presence of starch will turn black, to show if starch did or did not cross a particular membrane. Is that what you have?
Yeah. I didn't think it was black. I thought it was purple, but it doesn't really honestly matter.
Purpley black, we'll say.
Yeah, it's like a dark purple. But that honestly doesn't matter.
We always do it with salt and silver nitrate and some other things.
You're way better teacher than I am. So
I honestly do this with my 9th grade often. Not this year, but
of course, COVID.
COVID.
What was I going to add to what you said? Oh, So the ways that they could give you this on the test. So
yeah.
just so we're all clear, the labs are not required. Like, so it's not like they say you must do these 8 labs. So if they give you a lab that some students had done, other students hadn't, they have to describe the lab. They have to explain to you what would happen. What's the setup? What's on the inside? What's on the outside? Maybe what happened before, what happened after, and you're going to draw information from that given diagram. And so what they could give you is, say, a graph, and they had like the concentration of glucose, concentration of water, the amount of, concentration of water and concentration of starch. And so you would say, okay, well, starch would stay, constant because of the fact that it can't move. You would find that the water would have, maybe increased inside the bag, and then like glucose would decrease inside the bag because we're seeing that it's moving out. And so you would have to be able to understand and apply information.
Yeah, they might give you they might give you mass measurements, and from those mass measurements, you can talk about the movement of water. The other thing about, now that we talked about labs, one of the great things that has come out of being online so much the past year is so many wonderful teachers have put labs online, like time lapses and explanations of a lot of really common AP labs and even regular bio labs. So it's worth like a sit down, just walk through some things, especially if you haven't done some of the seemingly traditional style labs. It'd be good to just kind of get your feet wet with those. And then, explain the information on the other side. Like, do you understand what happened and why, and how that connects back to the content? Because that's where it kind of comes full circle for you. Could you direct us to those labs? That's a great question.
Bozeman biology.
Bozeman has
search
some
Bozeman
really
biology
great ones.
or whatever lab it is you want. And that amazing gentleman, Mr. Paul Anderson, has already made it for you. He made those labs when he was still in the classroom, and they were for his students, and now we all use them. Yes. So I have my students, actually, there's a video that goes through, it's the old labs, but it goes through lab 1 through 7, and then there's one that goes through 8 through 13, and my students are required to watch those for their review notebook that they're working through. And if you want my review notebook, it's already posted in my website in case you wanted to see what the review notebook was. Anyways, so before we get into this question I just posted, I want to talk about the different types of transport, because they're specifically talking about active transport. But so before we jump straight into that, let's kind of give a quick overview of the different types of transport. You want to go?
It's a great flowchart diagram. Draw it. Even as we're talking, you got to draw it. So first up, we're going to do, we'll take active, passive. Let's just split it. I can do passive if you want to do active. A lot of later unit questions coming in. All right, so first off, transport. We have active and passive. When we talk about the difference between these two types, there's structures involved, but the primary difference is use of energy, as well as ATP, use of energy, as well as direction of flow. Is there an answer key?
That's how I answer that.
Okay, so passive transport is going to flow using the kinetic energy of the molecules. They're bumping into each other, and they're going to generally, but not all, move from where they are more highly concentrated to where they are lesser concentrated. So if we're using our tonicity words, hypertonic to hypotonic. Things are going to flow by passive transport. They could use a protein. That would be called facilitated diffusion. They can also, if they are small and nonpolar, diffuse directly through the membrane itself. So those are things like some small steroids, like we talked about previously, your general gases, your oxygen, your carbon dioxide. And even though water is polar, water can also diffuse. So those are all going to be on your passive side, high to low, as well as not using ATP as an energy source. Be mindful when you talk about movement of molecules, there's no up, down, left, right in 3D space. Just because the diagram is showing it from the top of the screen to the bottom of the screen, or whatever the diagram says, it's going to be labeled. So intracellular, extracellular, you want to use your terms.
You must use your terms. If you are just saying, from one side to the other, you will not get credit for AP exam, because that is too vague. So you got to be very specific when you say them. So are you good on your passive?
Yep, you're active.
Okay. Active transporter, as she said before, requires ATP. And so I honestly wasn't listening 100% because I was trying to answer the question about our review notebook. Did you mention carrier channels?
I didn't mention anything specific. I just said facilitated diffusion.
Okay, so there are two different types for facilitated. There was the channel, which is just coming through this hydrophilic region. And then there's the carrier where it binds, changes shape, and opens on the other side. And so that's what's happening with the NAK, ATPase, all of those active transports. Those are, you're going to bind, we're going to bind sodium to it, which will then add the ATP. It has conformational change, opens up the other side, releasing it, and then 2 potassiums will bind to come on the other side. And so I have a crazy way to remember it. So
let's hear it.
Well, of course, somebody already asked something about action potential, so I'm kind of leading into action potential just because I know the other questions that are in the question box. But somebody wants to know about like how the whole thing with action potential works. And so we're going to have channel proteins. So we have the sodium channel and a potassium channel. Notice that I said sodium channel, like as in the only thing that can go through a sodium channel is sodium. And a potassium channel, the only thing that can go through is potassium. It is going to be the correct size and shape. Sometimes it has the right charge to bind to it. Okay, so they are specific for what travels through them. So Grandma, Nana, Na, sodium, comes over to visit, right? So she comes into the cell. So the first thing that's going to happen with action potential is sodium flows into your cell. After the sodium flows in, the kids, K, or potassium, they don't want to be in the house with Grandma because Grandma keeps picking their cheeks and bugging them, right? Asking them questions. They don't want that. So the kids run out or they leave the cell, okay? That's another part that happens with our action potential. That's kind of the repolarization that happens. And then we then have our sodium potassium pump, which helps to kind of reset our membrane potential. Membrane potential is just the voltage of the membrane. And so we have to kick Grandma out. So you then take 2 sodiums and bind them. And then you push Grandma out of the house. And so then you also have to bring those kids back in because it's too late at night for them to be out. So then you pull the kids back in. And so you bring in 2 potassium. So 3 sodiums out and 2 potassiums come in through the sodium potassium pump, which then realigns our membrane potential, which is our voltage or the difference of charge on the 2 sides of the membrane. There was, I believe, a negative on the outside and positive on the inside. No,
right, negative.
It's positive 40. On the outside and negative on the inside.
So a question I always get with this is how can you get negative things from 2 positive ions moving, right? How can you, right? So that's a little confusing. We think about it's relative amounts. So which side is more positive at times as compared to the other? And let's come back to what is a cell membrane made of? So obviously phospholipids, but like a whole host of other things as well. Ton of stuff. I mean, from the intracellular to the extracellular, you have your embedded proteins. You have those that are peripheral, those that are transmembrane.
Phospholipids are a type of macromolecule made up of a glycerol that's attached to 2 fatty acids and 1 phosphate. And so they make this polar region, which is your phosphate head, and then the non-polar region, which are your fatty acid tails. Continue.
So we have a lot of things in that membrane. So embedded is a term you're going to see a lot because things are within the membrane. But remember that the phrase is fluid mosaic model. It's not stagnant. So things are shuffling through the membrane and moving around on the surface, both internally and externally. And you also have your anchors, your cytoskeleton on the inside. You're going to have extracellular glycoproteins, glycolipids, things involved in cell communication or linkage, anchors, a lot of things.
Good. Okay. So I think we have time for one more question, and it kind of connected to that, the membrane transport that we mentioned before. Can ions diffuse passively through the membrane, or do they have to require a protein? And if so, what kind of protein will they use?
They're charged.
So
large and charged, not going to pass.
polar and will not pass. So they require some type of protein. And so as we mentioned earlier, it can either be a carrier protein or a channel protein, depending on whether we're looking at passive or active transport.
Active. Yeah.
So anything last minute you want to say to our lovely?
I'm trying to think, do we cover everything in
penguins?
this unit today? So we have
there's too much.
structure, function, different cell types, movement of molecules. Whew, it's a doozy. It's a hefty one, but it's not one of the most weighted on the exam.
I don't remember the weight
traditionally.
On this one.
I think
I don't think I have it written down next to me. I've got the 3 responses next to me, but not the.
Yeah.
Ooh, actually, I have it. Well, I don't have the percent, but I have the number of questions. So there's going to be between 6 to 8 questions on this in the exam, which is not one of the heavier weights. It's a medium weight. Difference between carrier versus channel protein. Someone just mentioned that in the chat. Channel protein is a tunnel. Carrier protein,
gated or not.
Yeah, gated or not. If it's gated, then it means you have to bind something to it in order to open it, to allow it to have something go through. Versus carrier is going to actually have a conformational change to open up on the other side. I usually have like this, you're about to see a water molecule, just go with it. I usually have like an actual like pill or these stress balls in my classroom. So what ends up happening, I just happen to have this water molecule nearby. Just deal with it. I know it's not going to work so well. So the carrier protein is going to bind to one side of the membrane, and then the carrier protein goes through conformational change, which as it changes shape, then brings it across the membrane. So that's the way the carriers work, is that they have the shape change that brings it across.
Yep. And so for the sodium potassium protein that was discussed earlier, it's going to be moving things in both directions. You end up with this like seesaw effect that functions that way. Heard it's in school only.
There's only one exam that was changed due to the pandemic.
Physics 1 was changed.
They cut 2 units. Yeah.
Yeah.
But our exam is going to be a full exam. It is a full 3-hour exam. And just quick, since we have 3 minutes left, make sure we mention this. There are 3 different test dates. The first test date is a paper exam, and the second and third are virtual exams or digital exams.
Yep.
What we know so far is that you cannot go back on the virtual exam or on the digital exam. You could take it either at your school in person, digital, or at your house. And once you move past the question, you cannot go back to it. So
I feel like that's going to be really hard for pacing.
Personally, I'm telling all of my students that I want them taking the paper exam because I want them to be able to, you should be able to go back. A test-taking strategy that all teachers teach you. If you don't know the answer, move on, you can come back to it. But on a virtual exam, you won't be able to. And you don't know how much time you're going to need for your future for responses. Like maybe you finished the question early and you're like, oh, should I move on? If I move on, I can't come back and check my answer. And so I would honestly stick to that paper exam. I love you all, and I don't know how your teacher is, but I don't know how much more information you're going to get in those 2 weeks in between those exams to make it worth the disadvantage of not being able to write on the exam. You can't circle things. You can't highlight things. You can't make notes to yourself. And if you think you're going to be able to use notes on a virtual exam, you're mistaken. Talk to anyone from last year's exams. Okay. They had opened the internet.
They were busy.
They could open anything and they could not get answers because those questions were written knowing that students were able to access those materials. And I bet you money, this year's exam is probably written the exact same way. The virtual exams will probably be written in a way that you probably can't look over those answers because they know you're at home. They know that you could have a textbook next to you or notes next to you. Although we can say all they want, no notes, none of this. They have to write in a way to ensure that you don't.
And so much of it, like we said, is application based. So factual information, even on the paper exam, factual information is just only going to get you so far. In your explanation of information and going back to the prompt, whether it be in multiple choice or FRQ, is going to be always a piece of how to find success. I saw a question about what score to get a 4. So
So I wouldn't go with that. I probably have those numbers, but it's based on old data. I'm going to be honest with you students. The data that the teachers have is based on 3 practice exams that were given to teachers only. And they were never tested with students. So we are assuming that these would be the numbers. And I believe, I only looked up the 3. You have to make 54 out of 120 points to make a 3. So you just got to get a little less than a 50. Was that a 40%, a 40 something? I think 54 out of 120. It's somewhere in the 40 ballpark.
We teach bio, not math. What are you talking about?
You can't say that I teach math too. I teach pre-cal.
Oh, you didn't know that? Oh, man.
I was a pre-cal support teacher for a while.
Physics for a while, which is very mathy.
Yeah. And somebody said real fast before we log off, I'm going to make this our last question, then we're going to move on, and we're going to say bye. Somebody said, will the virtual be harder or equal to in person? I have no way to know either way, but I will free your mind slightly here, okay? There are some very brilliant people who work for ETS, who is the one who makes all the exams for College Board. And these individuals have some advanced degrees, and they make a lot of money to ensure that no matter what questions you get, your score will be comparable to another student taking the same test. This happens from year to year. This happens from version to version. Every year, even when we were in person taking exams, there was at least 3 different versions of the exam. And they always made sure that those were comparable. So if you made a 3 on this exam, you would have made a 3 on any of the exams going back in the past, going to the future. So no matter if you're taking the paper pencil exam or the virtual exam, your score is going to be comparable to a student who took any of the other days. So don't freak out about that. Anything you want to add?
No, I think, it's not, honestly, and it's easy to say, it's not worth getting anxious about that, what you can't control, but it's true. They're going to be as fair to you as possible, and focus on the day, and recognize that it's only one day. We're going to be here to help you over the next couple of months. So please, continue to follow along with both of our pages. Tiffany, do you have anything coming up you want to let them know about?
I started doing FRQ Fridays.
Yes,
so every single Friday, I will go through a certain number of FRQs that are about the units that we're currently on the daily reviews. So if you feel like you're struggling on FRQs, you could definitely check those out. It will give you a little bit of information on how to approach the questions, what kinds of things could you have been looking at, how can you pull information just from a diagram that you may not actually know information about, how can you work the points.
Yeah, that's awesome. I'm excited. Yeah, I can't wait for my students to watch them as well. I linked your YouTube channel to their course page, so you're welcome.
The next one's on Friday. They're every Friday.
They're every Friday. Yeah. So we our schedule for these lives is also posted about every 2 weeks. A little different in April, and then we have for myself and the APsolute RecAP, we have about 10 or 11 episodes left of this season, but we are already. Today, this week we had episode 70 come out. So we'll have about 84 episodes released by the time the exam comes. We're also hosting courses and review classes online in April for those of you who kind of want to have a more intimate review with a smaller group of students. So if you're interested in that, you can find that on our website.
Okay. Well, thank you all for joining with us. And remember, you are all penguins, so you are all dressed for success.
Awesome.
Bye, y'all.
Bye.